Welcome to our workshop on exploring coding presented by Code Club Australia. My name is Kay North. I am the manager of Code Club Australia and have been for the last 4 years. Prior to that, I was a primary school teacher in classrooms for over 20 years, specialised definitely in the STEM subject areas, which were my absolute favourite, but also worked in schools as a digital technology specialist, had a role as a STEM specialist, and also spent 4 years in regional office where I was tasked with building teacher capability in the STEM subject areas, as well as supporting schools to develop STEM school action plans. So definitely my wheelhouse. I was super excited to move into the role of manager of Code Club Australia because it was a resource that I had been using in my classroom for over 8 years. I'd used it to help me teach coding to my students before it was even a recognised curriculum area. And also did run a lunchtime code club for my students, which was heaps of fun. So today's workshop is all about what can we do to support teachers in schools, whether you are a tech specialist or if you are just wanting to explore coding or you are tasked with this in your classroom. What resources can Code Club Australia share with you and give to you at no cost to be able to support that journey? For you, those of you who don't know or haven't heard of Code Club before, we are a worldwide organisation that all have the same mission about embracing and encouraging and building digital skills in our children. It's about giving them the skill set in a safe place to be able to come up with digital solutions that support them in their life and in their local community. So these clubs are run in 72 countries around the world, led by amazing volunteers that give up their time to run these clubs, whether they are in libraries, community halls, community spaces, neighbourhood centres, homeschooling communities, but more and more classroom teachers and a lot of classroom lunchtime clubs too and after school clubs. Code Club itself was founded in 2012 and started in Australia in 2013 and joined teams with the Raspberry Pi Foundation in 2015, which has only embraced and improved the work that we do, knowing that the research that the Raspberry Pi Foundation does embeds and embodies and underpins everything that the Code Club does with our projects and our coding knowledges. So a little quick video snapshot of our website. This I encourage you to take some time to explore. Make sure you go to codeclubau.org and here you will find a wealth of free to access resources to support teaching coding. In the projects area, we have over 290 coding projects with all step-by-step instructions. You can search through them through the topics and look at what's available. You can also search through in what programming language you are looking for. Either way, you're going to find a ton of projects. You can also put in a keyword to see if you can find something specific that you are looking for. So each of these project tiles here are a brand new project with step-by-step instructions. When you choose a project, the project page will give you more information. What will kids learn if they complete the project? What will they need to be able to make it happen? As well as for teachers, curriculum alignment. I have spent many, many hours making sure that this alignment is good to use. The alignment is there for version 8.4 as well as version 9 of the curriculum. You will find the achievement standard highlighted for what is being achieved, as well as whether it meets or doesn't meet the content descriptors for that band level. For each of our projects, you can download the PDF instruction sheet, and in my classroom and code clubs, these will be photocopied and laminated to keep forever. But then the ones that Raspberry Pi have created, you can also load the online instructions. So these are web pages that you can slowly step through to be able to go through each of the instructions. Both are going to work, just depends on what suits you and your situation. What I find as well is that lots of teachers don't actually provide these project sheets to their students, it actually becomes their lesson plan to be able to teach how to do the coding to their students. So on the screen here, you will see an example where we've got the PDF with the instructions here, and then the Scratch screen where your students, even yourself, if you're having fun with the coding, are following those instructions to create the project. The idea with the projects is that the instruction sheets are teaching and guiding as you are creating. If you follow it step by step, you will finish with a complete project that is working, that you don't have to debug, you're not sure what's not happening. It's all there set ready to go. But in Code Club, we really encourage our kids to personalise the project as we are going. So it's a bit like art class where we're all sort of working on the same skills, but our finished product are all going to look the same. Our coding projects should really do that, allowing children to personalise with their content, their knowledge, their skill set, and being able to have something at the end that truly represents them. So if I delve into our learning paths, these were developed by the Raspberry Pi Foundation in a way that it really sets our kids up for success. It follows what they call the 3-2-1 MAKE methodology. So the research into this was looking at how do we develop the knowledge and skills for our young people while at the same time as being motivating and fun along the way, with the aim of having our kids being able to say, I can make things. This is cool. I see myself as a creator. I want to be able to create and design things that matter to me. If I don't know how to do something, I know where I can go to find it out. These are the things that we embody as we're working through the projects. So how does the learning path work? 6 projects, just 6. The first 3 all focus on explicit teaching of skill sets. And for example, if we're using the Scratch learning path, it's teaching the coding blocks as we go and what they do. And those first 3 projects build on a variety of different skill sets working towards an end product. Next 2 projects, so projects number 4 and 5, are design. So still learning some new little key pieces, but at the same time, the amount of instruction is pulled back. So giving kids a chance to go, I learned how to do it in the first 3 projects. I can have a go myself this time. But if I'm not sure, I can open up the hints and get the information that I need to be able to be successful. The final project, project number 6, is a design brief. So it's not going, here are the instructions to follow. The design brief is, you've learnt these skills, you're going to create a project like this on your topic. So show us what you can do. And it's always amazing to see what our young people come up with. Let's jump into one of the learning paths to make that look a bit more cemented in what it happens. So I've chosen the Introduction to Scratch path. This one is brilliant for our haven't touched Scratch before children and adults to be able to learn about using Scratch. The first project starts with Space Talk. And Space Talk really clearly teaches, how do I add a backdrop? How do I add a sprite? How do I add some sound? And how do I make the sprites change costume? It finishes with a cute little animation at the end. The project itself, if you're an adult who's never done Scratch and you're starting from the beginning, might take 15 or so minutes. But in a classroom, 40 minutes to an hour in a session would be great, because you're letting the kids build and create, but then let them personalise and play around with the code. The second project, called Catch the Bus, introduces movement blocks and how sprites are positioned on the Scratch page, and it also introduces the repeat loop. So here we're looking at iteration, repeating the same thing over and over again, and it reinforces those concepts of background, sprites, and costumes. The third project is Find the Bug. Here again, we are reinforcing our concept of backdrops and of sprites. We reinforce movement from project number 2. We extend their knowledge of iteration from a repeat loop to a forever loop. And it also adds in a timer variable for those kids that are ready for that. This project, if you kind of think like, where's Wally? This is what we're going for. So here are our first 3 projects where it is explicit teaching, it is explicitly learning some skills and scratch coding blocks, and we've created 3 projects already. When we jump to the 4th project, Silly Eyes, there's still some explicit teaching because we're learning about the editor tool and we're learning about user interaction, but the instructions are paired back for the other elements that we've learnt in the first 3 projects. This one, the kids absolutely love. They create a cute little character, but in the project itself, as you move the mouse around the screen, the eyes of the character follow along. So it's really cute. It's really fun, and the kids absolutely love it. Project number 5, Surprise Animation, is about pulling together all the skills that they've set and practicing it one more time. How are they going with it? Have they nailed it? Do they need any more support in any of those areas and another chance to practice? And they finish with a cute little animation. The final project, number 6, the design brief, is called I Made You a Book, where the task is to make an interactive book. So the students are going to be able to demonstrate their use of adding in backgrounds, adding in sprites, movement, interaction pages. They can add in iteration. They'll be doing debugging along the whole way. So they're showing all these skills by creating their own project. But the beauty of I Made a Book is that the topic is whatever they choose. So in a classroom, this is a great task to be able to put forward for assessment. You could allow them to just have freestyle of choice with their book. What that does is give them ownership, and it reduces that working memory. They're not trying to learn something new to share in a book. They're just being able to focus on the coding. But it can also be that this is integrated with another subject that you're currently teaching or have already taught. So the book itself might be demonstrating the food chain that they've been studying in science, or it might be a story where they're rewriting a story that they have read in class. It could be that they are mapping the movement of the convicts from England over to Australia. It can be absolutely anything that you choose it to be, but really great when you can integrate it with another subject area and kind of tick off a couple of things at the same time. So that's our first learning path. Teachers that have been with us for a really long time will often refer to Module 1, which was a series of 6 projects that kind of linked the skill set together. And it's still a great option, still found on our website too, but our learning paths are just that bit more academic and a bit more rigorous in the teaching, and that slowly pulling back of instruction to be able to let students show exactly what they're doing. The second learning path, just so you can kind of see the jump in skill set, the second learning path moves more into gaming environments as opposed to the first one, which was more animations and storytelling. So in the second one, it is bringing in the broadcast function, so being able to send a message to other sprites to tell them when to start certain actions and run an algorithm. It leads into branching, which is fantastic for our year 3, 4 band of curriculum. Brings in the randomization tool, brings in sensing and variables. So all these things that are coming in to turn into that gaming environment is where the kids really do love to be able to work. So in this one, the final design task is this sprite needs you. It's all about being able to feed a pet and making it grow, kind of think like Tamagotchi style. So kids are creating that kind of environment, that kind of game at the end. So our learning paths, we've got multiple learning paths. We have got over 10 at the moment, which is so fantastic to be able to offer. We have 3 learning paths that cover Scratch. We've got one for microbit. We have 2 for HTML and CSS. We have 2 for Python. We have 2 for Unity, which is awesome for our junior high schools. There's also an AI toolkit. The AI toolkit itself isn't a learning path and sequence learning. What it is experiences with lots of different AI applications and technologies to create exposure. In Australia, on our Code Club Australia website, I have worked very hard over the last 4 years to build a whole group of very specialised projects that are just for our Aussie kids and focus on Australian content. So I have come up with a learning path that's focused on game design, but does work just around our Aussie context. So it starts with creating a simple shadow game with some basic skills of being able to move sprites around, moves into a quiz. There's 2 quizzes there, one for Northern Territory and one for Tasmania. This one really fits into our Year 3-4 tech band. I know our curriculum talks about ideas around making a true-false game or something similar like that. So this is a very set task focusing on that. The next task is the electrical safety catch. This one was made in collaboration with Ergon Energy. It rolls out each year around Electrical Safety Week, but it's a really fun catching game. Kids really love to be able to play, but it does introduce great things like being able to mimic gravity, creating clones, and use the input. Moves into the game kickoff. This one was designed to celebrate our state of origin between Queensland and New South Wales. It's basically the Pong game, but very much personalised for our kids. Moving into Yulunji Quest, this one was a fantastic collaboration with the Yulunji people in North Queensland. They share with us their knowledge of picking lily pillies and what that means during the right time of the year. Also introduces parallax, which is mimicking that character walking on screen because the background is scrolling through. Really cool game environment, that one, heaps and heaps of fun. And then it moves into a design brief of space junk where we have this concept that out in space there is tons of junk that we have put out there, but what do we do to be able to inform people about this and what can we do to help solve the problem? So there's heaps and heaps of examples of the projects, of everything that is available. And remember that each of these projects that we share have those instructions there, whether you are using that as your lesson plan or whether you are giving it to students to be able to follow. The principles behind that 3-2-1 make pedagogy, it's about prioritising fun and engagement with the coding process while leading to outcomes and leading to finished products. I always say when I'm working with people that coding itself is not about learning the language of coding. It's about the computational thinking skills that we're developing as we are coding. I can get to the end of a term working with U4 students in Scratch and building games, and I would say that a large number of those kids still don't know what the blocks mean and how to put them together. But when I've seen growth across the year where they have been resilient in their work, they've been looking at debugging, when they've been able to break something big down into smaller, achievable parts that they can do, when they're working with a team, when they're talking with others and asking questions and finding solutions, these are the thinking skills that we want to develop in our students. And that is the whole point behind our curriculum. The technologies curriculum is all about creating digital solutions for purpose. So these learning paths are a great tool to be able to support that. The learning paths build independence in our students. They're learning as they are going. It greatly encourages personalisation, which is sometimes a real blocker. Every one of those projects will show you the curriculum alignment within the lesson plans, and the materials are all there set and ready to go for you. Code Club Australia, as I said before, is a completely free resource for teachers, but I do encourage you to register your classroom or your school as a club. What it does is give you access to a whole bunch of other resources for free that will support you on the teaching journey. There are a whole wealth of certificates, of tracking sheets, posters. There's a planning template for making your own project. There's how-to guides, and there's a whole stack more of those free resources in there if you choose to register with us. If you are a registered Code Club, you can reach out to me at any time for support. I am the only person behind Code Club Australia, and I support all of our clubs. So I'm really happy to be able to reach out and help with everybody. If there's something specific you are looking for that we don't have, you can reach out to me and I can see if it's something that I can be able to create, make, share. I can pass you details of somebody who might not have that or might have that. You join a network of incredible volunteers across Australia. We've got about 2,500 people who are part of our network, and it's great to be able to draw on their expertise and their knowledge. Each term, Code Club Australia runs competitions with great prizes for registered clubs. This term, I released a coding project in Tinkercad using Tinker blocks to create a fidget spinner. So heaps of fun, and I've offered to print fidget spinners for any of our registered clubs who don't have an access to a 3D printer. But the competition itself is to design a moonhack trophy, and I'm giving away 2 3D printers this term to the winning projects. So each term, there's some really cool competitions and prizes that you can be part of. You'll get access to specialised projects if you are part of our registered clubs, and having registered clubs will ensure that we can keep Code Club running across Australia. There's lots of training and support that I can also offer to clubs across Australia. On our website, you will find our training page. We run some online e-learn courses so that you can do them in your own time, at your own pace, but they're designed to help you. The Code Club in the Classroom e-learn course is the equivalent of 5 hours of teacher PD. And for anyone in the ACT, this is TQI accredited for 5 hours. So you can use that towards your necessary hours each year. If you're looking to learn more about Scratch, I have the Scratch Coding Mastering the Basics course, which is accredited for 8 hours of teacher PD. Both of these courses, we are very fortunate that the Telstra Foundation is paying for access to the learning platform. So that means that anyone who registers can complete the course for free. We also have a YouTube channel where I upload code along videos when I get a chance to make them. Workshops such as this one will get uploaded and shared there too. So it's also a great resource to be able to access. So I'll finish with my details on the screen. Please reach out if I can help and be of assistance in any way. Feel free to go check out our socials, jump on the website, have a look around. And like I said, if you're a registered Code Club member, you can reach out to me at any time for extra support and whatever I can do to help you.